If you look at a hyperbola, right, it has these four directions where the hyperbola sort of stretches out infinitely far, and it kind of looks like these might be approaching some sort of asymptote. It looks like maybe a hyperbola has two asymptotes that are crossed at the origin like this. To figure out if that's really the case, and if it is the case, what the equation of these asymptotes are, we need to start with the equation of the hyperbola and then ask ourselves what happens when x and y get very large. If we make x and y, so if we take a point on the hyperbola x comma y and we make x and y large, that means we're sliding out along one of these extreme directions of the hyperbola. So let's start with the equation for a hyperbola. Since this hyperbola opens right and left, we need the version of the equation of a hyperbola that has a minus sign on the y squared term. So here's an equation for our hyperbola. And to get a handle on what the asymptote might be, right, if we concentrate just on this upper right part, it looks just this upper right part is a function, right? Just the upper right part passes the vertical line test, so we could solve this for y as a function of x. In other words, we're going to take this equation and just solve it for y, but choose the positive possibilities for y and not the negative possibilities. Okay, so to solve this for y, I guess we need to move the x squared over a squared to the right, so that gives us minus y squared over b squared equals 1 minus x squared over a squared. And then multiply both sides by minus 1, just to get rid of this minus sign on the left. Y squared over b squared equals x squared over a squared minus 1. And then multiply both sides by b. We get y squared equals b squared times x squared over a squared minus 1, and then take square roots. So we get y equals the square root of b squared times x squared over a squared minus 1. Okay, of course we took a square root on both sides of the equation, so we should have a plus or minus. But remember, since we're using just the top half of the hyperbola for this thought experiment, we don't need the minus possibility. That would give you the bottom half of the hyperbola. So we're going to use the positive possibility here. Now remember, we're trying to figure out what happens when x is big. Okay. Well, when x is big, this turns into the square root of b squared times, say, big squared over a squared minus 1. And if you take a big number and you square it, divide by a squared, subtract 1, and multiply by b squared, it's still really big. So this whole mess is still going to be very, very big. And that doesn't really tell us anything. So leaving our expression for y written like this doesn't really help. So let's see if we can mess around with this expression algebraically to see if we can make anything nice happen when x is big. So one thing we can do, this isn't really an obvious thing to try, but it turns out that it works well. So one thing we can do is, first of all, we have the square root of a product. So let's split up that square root. So it's the square root of b squared times the square root of x squared over a squared minus 1. Okay, now this is seems like a step in the right direction because this square root of b squared, that's just b, times the square root of. Now inside of this square root, what I'm going to do is factor out x squared over a squared. And again, this is not an obvious thing to try, but it works out. So when we factor out x squared over a squared, factoring out x squared over a squared from this first piece leaves behind just a 1 minus And now factoring x squared over a squared out of 1, that's a little bit tricky, but what it leaves behind is a squared over x squared. If you're not quite sure that this is right, remember you can always check that it's correct by distributing the x squared over a squared and checking that we do get back to this stuff in parentheses, x squared over a squared minus 1. And it does work out. Okay. Well, now look, we have another product inside of our square root. So we can write this as b times the square root of x squared over a squared times the square root of 1 minus a squared over x squared. Okay, so this is y equals b times, now the square root of x squared over a squared is x over a. Well, really it's the absolute value of x over a, but remember we're working only with the upper right-hand part of the hyperbola where x is positive and y is positive. So this x right here, we're assuming it's positive from the beginning, so we don't have to write an absolute value here. Okay, times the square root of 1 minus a squared over x squared. Okay, now remember, let me do one more thing. Let's write this as y equals b over a times x times the square root of 1 minus a squared over x squared. Okay, now remember, in our hyperbola, we were asking, so here's our hyperbola, we were asking, we think we have an asymptote here. What is that asymptote? And we decided we need to think about when x is big. Okay, now this x right here, if x is big, this x just makes everything huge, right? But this x is to the first power, and so that's going to sort of describe what the asymptote is doing. So rather than just plug in big X everywhere, let's do it just for the second piece, because it's the second piece that sort of it gives the hyperbola its nature. So let's imagine what happens to this square root when X is big. So y equals b over a times x times the square root of 1 minus a squared over big squared. Okay, so what happens here? Well, if in this fraction, the denominator is getting big, and when we say big, we mean really, really big, right? This hyperbola goes all the way out towards infinity. So this denominator is getting very, very, very large. And when the denominator of a fraction gets very large and the numerator stays the same size, the fraction gets closer and closer to 0. So this fraction is going towards 0, and 1 minus 0 is 1, and the square root of 1 is 1. So when x is big, this whole square root part is about 1 times x times b over a. Okay, so what this is telling us is that when x is big, your y-coordinate on the hyperbola is approximately b over a times x. But that means that this line right here has the equation y equals b over a times x. So it is an asymptote, and we have the equation for this asymptote. It's just y equals b over a times x. Of course, you can do the whole argument thinking about the other asymptote and keep the bottom half of the parabola, and you get an equation for the other asymptote. It won't surprise you to find that it's y equals minus b over a times x. So the short version here, to put together everything we know about this hyperbola, its equation is x squared over a squared minus y squared over b squared equals 1. The focal length, the distance from the center to the focus, that's c, and c squared is a squared plus b squared. And the asymptotes are y equals, there are two asymptotes, and there's y equals plus b over a times x and minus b over a times x.